Hi, we're getting ready to do the how do electromagnetic waves interact with matter. I know this is kind of a crossover, and I find that a lot of the stuff that we do tends to cross over to the other things that we teach. If you want to, this can be obviously be used when you're talking about rays of the sun, when you're talking about layers of the sun, astronomy, and all that. You can also bring it back out and do it during waves when you're teaching about waves. So you're going to get this great toy. It was actually invented back in 1873, and it was created as a toy. It is. I always tell my students that it was the Xbox of the late 1800s. You know, it is great. But it's a radiometer, and you're probably looking at it saying, "What does this thing do?" Now, what I've always done is that a lot of times these things will come with a little sticker on the bottom. Take that off, and that's because kids, when the students when they get it, they're going to pick it up and they're going to look underneath. A lot of times they'll put the information underneath, so you don't want to give them any hints or any clues. Now, what I usually do is I torment my students and I tell them, okay, so what we need to do is we need to figure out a way to make this thing move, because obviously as you put it down, it's going to move a little bit and jiggle. Now, I try and get them to think about it. So there again, it's a problem-solving toy, I guess you would call it. And what they're going to do is they're going to figure out, okay, well, if I spin it like this, I said, no, can't touch it. You got to make it move, but you can't touch it. And then eventually, someone will say, wow, if I only had a flashlight. And so, of course, I give them the flashlight, I dim the lights, and what you're going to do is you are going to notice on the radiometer that there is a black side and a white side. And obviously the black is going to be absorbing the light, and the white is going to be reflecting it. And what's happening is there's a little bit of heat exchange at the top, and that's what's going to make it spin. We're going to pause it, and then we can. All right, so we got a little bit better close up here of the radiometer, and what you're going to do is they're going to take their flashlight and they're going to point it at the black panels, and it's going to start to spin. Now, I will be honest, some of these spin really good, some don't, but they will spin. Students love to play with these things, and you're going to want them to do an experiment with this. But I found that trying to do the experiment straight from the start is not going to work. It doesn't work out well. So let them go ahead and have the fun with it first, okay? Now, some students are going to say, hey, let's try two. So we're going to try, will it go, they're already experimenting, and will two lights make it go faster, And so they may put 2 flashlights up. I've even had students do 4, okay? Now, then you'll get students that will try smaller flashlights work? I don't know. See, we're still experimenting. We're still having fun. And, you're trying smaller ones. You're trying bigger ones. You're trying more. Then someone might say, well, what about different colors? And so what you're going to do is if you should have one in your box as a red light. And you can say, well, let's try a red light. So you try the red light, and just doesn't work. Just doesn't want to work. Now, hopefully, you'll also have a student that's going to say, hey, Mr. Stewart, I saw you playing with those lasers. Could we try a laser? And so you'll pull out your laser. This is the red laser. And you say, okay, lasers are really strong, because students will talk about how they can light matches with them and stuff. And so then you say, okay, let's try just a laser. Point at that black panel. So not moving very well. Definitely different from using the white light. And see, now we're starting to talk about the power of the light spectrum. So you've got red light, different lights, and they're like, oh, well, what if you had a more powerful laser? like a green one. So you should be getting a green one in your book or in your box. Green light. Let's see. And they're going to put it up there, and it just gets it going just a little bit. So what you can then have them surmise is that using a flashlight, even though the laser seems more bright, is actually more effective trying to get this to spin. Now, when you do the experiment, you can follow the lab that I have right here, and you can actually have them do the lights from different distances. And there again, you can always do some math if you want to. Use this experiment however you want. You can use it as a demonstration if you can get enough, if your budget allows to get enough for all your students or be in small groups or in a station, and it should work pretty well, and hopefully it'll amaze them as much as it amazes my students.